Okay, so today I will discuss the last chapter, code optimization. So the first slide is what is code optimization? Okay, and this is also the last chapter of this course. So what is code optimization phase? So when you see the compiler is divided into two parts, front end and the back end. So in the front end, the input is what? Source code, and the parts of front end is lexical, syntax, and semantic. After that, intermediate code generation, okay, and then code generation. So in between intermediate code and code generation, there is what? Code optimization phase. Okay, so compiler can optimize what? Intermediate code. Okay, output of the intermediate code is what? Intermediate code is IC, that means intermediate code, like three address code or syntax tree. So code optimization do what? Optimize this three address code and give the optimized code to the code generator, and then code generator change this optimized code into target program. So first question in this slide is, what is code optimization? So code optimization is the fifth phase of compiler. Okay, the first phase of what? I will write phase here for the, okay, number one, first phase is lexical analysis. Second phase is syntax analysis. And third phase is semantic analysis. Fourth phase is intermediate code generation, and fifth phase is code optimization. Okay, and the last phase is sixth, code generation. So fifth phase, what? Code optimization. So first point is code optimization is fifth phase of compiler, and it is used to improve the intermediate code so that the output of program could run faster and take less space. Okay, what is the output of intermediate code? Like three address code. So code optimization phase is do what? Code optimization phase improves the intermediate code. Okay, so this line improves the intermediate code so that the output of program could run faster. That means optimized code should faster and take less space in memory. Number third point, it removes the unnecessary lines of the code and arranges the sequence of statements in order to speed up the program execution. Okay, that means what? Code optimization remove the unnecessary line of code, okay, to make the program faster. Now, what are the advantage of optimized code? Okay, output of this is what? See, I will write here output. This is the phase of compiler, and this is the output of all the phases. So lexical output is what? Token. And syntax analysis output is parse tree, and semantic analysis output is what? Type checking. It checks the type. And intermediate code is what? Output 3 address code. And code optimization is 3 address but optimize code. Okay, optimize code. And code generation is what? Target code. So these are the output of all the phases. So now we are discussing code optimization, that is the optimized code. So second question is, what are the advantage of optimized code? So the first advantage is optimized code has faster execution speed. That means optimized code is faster. Optimized code utilizes the memory efficiently. That means it takes less space. And optimized code gives better performance. So these three are the advantage of optimized code. Now, what are the area of code optimization? Okay, so there are three area of the code optimization. First, local optimization, loop and data analysis. Okay, data flow analysis. Now, see, next slide we will discuss what is the code optimization techniques. That means if the code is given, so how you will make the optimized code or how you will make the code faster. So basically there are 5 techniques of code optimization. Okay, this is the code optimization. So the techniques is what? Compile time evaluation. Okay, technique number 1, compile time evaluation. Then common sub expression. Then dead code elimination. This is the technique number 3. Technique number 4, code movement. And technique number 5, extraction, strength reduction. Okay, so maybe the question, write the name of code optimization technique. So these 5 are the code optimization techniques. Compile time evaluation. In the compile time evaluation, there are 2 methods, constant folding and constant propagation. So with example, I will explain all the techniques. Okay, so the first one, compile time evaluation. The first technique, technique number 1. This is what? This is technique 1, compile time evaluation. So in the compile time evaluation, 2 methods is there. First is what? Folding and constant propagation. So first, what is the compile time evaluation? So compile time evaluation means shifting of computation from runtime to compile time. Okay, when you write the program, so there are your program have two stages. First is what? Compile time execution and run time. So what is the compile time? So when you write the program and compile, That means when you compile to check the error, so this is called the compile time. And when you run the program, so it is called what? Run time. So compile time evaluation means what? Shifting of computation. That means whatever the computation from run time to compile time. Okay, so two method is there. For example, length equal to 22 divide by 7 into d. Okay, so when you write the program, I mean in the program, if this expression is there, length equal to 22 by 7 multiply d. So this, what is the value of 22 point divide by 7? This is calculated at the compile time. Okay, when you compile the program, so it is replaced by 3.22 divide by 7. 22 divide by 7 is what? 22 divide by 7 is 3. 3.142. Okay, so value of this is what? 22. So 3.142 multiply d. So this 3.412, that means when you compile, so this calculation, this computation is done at the compile time. Okay, so this is called what? Constant folding. Now constant propagation is what? So in this technique, the value of variable is replaced and computation of an expression is done at compilation time. That means maybe pi equal to 3.14, r equal to 5. And when you write area equal to pi into r, so the value is replaced, pi equal to this. So the value, that means what? 3.14 into 5 into 5. So the value is replaced at the compile time. Okay, not at the run time. That's why it is called what? Compile time evaluation. Another example is what? See, if you will write here a equal to 5 and b equal to 6, right? And s equal to a plus b, this. So what is the value of a and what is the value of b? So this calculation is done when you compile the program. Okay, so not at runtime. If runtime, then what? It will be slow. So that's why it is calculated. The computation is done at the compile time. Okay, so that's why the runtime is what? Faster. Now, second technique. So second technique is common sub expression elimination. Okay, that means what? See here, if this is the code, right? S equal to 4 multiply I, S2 equal to A S1, S3 equal to 4 multiply J, S4 equal to 4 multiply I, S5. So this is the sum code. So here if you will see, so in this 4 multiply I, this one, this statement and this statement is same. 4 multiply I, 4 multiply I. So that means what? 2 times. That means what? This is what? Common expression. So here how many line? 1, 2, 3, 4, 5, 6 line is there. That means if the computer process this 6 line, it will take more time. So that code is slow. That means here 6 line. So common line you can remove. Remove the common line, remove the common sub expression. Okay, So S1 4 multiply I, S2 S1 same, S3 4 multiply J, and 4 multiply I. So no need because 4 multiply I already there. Okay, so remove here in code optimization, and S5 equal to N and S6 equal to B S4. So what is the value of S4? 4 multiply I, and also value of S1 equal to 4 multiply I, same value. So put here S1 plus S5. So here how many lines? 1, 2, 3, 4, 5 lines. So this code is faster. Okay, so in this technique, what you will do? Common sub expression elimination. That means what? Remove common lines. What? Removes common code. Okay, so if we in the exam explain any three or explain any two code optimization technique. So this is the one technique, common sub expression elimination. So here what? Eliminating the common sub expression. Okay, now second is what? Copy propagation. Third technique, copy propagation. So copy propagation means what? Use of one variable instead of another. For example, here x equal to pi and area equal to x multiply r multiply r. So what is the use of x? No need. You just, maybe if I will write here, suppose x equal to a, right? And I will write here s equal to, okay, x plus b. So this is what? This is the unnecessary line. Okay, x equal to a. Why I will assign this one? No need. We can directly put here what? S equal to a plus b. So no need of this. Okay, x equal to a, what? That means we are unnecessary. Here how many? 1, 2, 3 lines. Okay, so the computer will process these 3 lines, so it will be slow. So no need of this x equal to pi. Direct, okay, in a one line. So that means what? This here 3 line, process 3 line, but here if you will write s equal to a plus b, so it will process only one line. So it is what? It is slow. So copy propagation means what? Use of one variable instead of another. Number 4, code motion, or it is also called what? Code movement. Code movement. Okay, so in this technique, what we do, we move some amount of code outside the loop and placing it just before entering in the loop. So for example, here you see, this is the program code. So for integer j equal to j less than n, j plus plus. So here, see, in the loop, how many lines? 2 lines. That means maybe suppose here I will write if 4 I equal to 1 and I less than equal to 10 I plus plus. Suppose this one. So this how many times? 1 to 10 times. That means 10 times do this operation, x equal to y plus z and aj equal to 6 into j. This means this 10 times, so 2 line. 2 line it will process, so that means total 20 times it will run. How many times? 20 times. Okay, because 10 times, so 2 lines, so 10 into 2, 20 times. Okay, so in the code movement techniques, what you will do, you will take some amount of code. That means if x equal to y plus z, so here uh, I is not here, right? And this is what, this is not j. If I will write here, so see, this is I, because I will write here in the for loop I. Okay, so here in this line you see there is nothing related with I, but here I is there. So you move that code without I, you move that code here, x equal to y plus z before loop, and start the loop for I equal to 1, I less than equal to 10, I plus plus. Okay, and here what, ai equal to 6 multiply I. So now one line, so one line you move outside, understand? That means here this 20 times, now this how many times, this code will one time this one time. Okay, and this line how many times, 10 times, so total 11 times. So which is faster? This is slow, and this one is what, faster, because it will execute only 11 times. Okay, so in this techniques, what you will do in this techniques, you take some amount of code. That means here j and here j, so you cannot take this outside, because this value is depend on j, but here no j. So that means you can take this code and put outside before the loop. Okay, so that's why you can make the code faster. This code is what, slow and take more space, and this code is faster. Okay, so in the code movement techniques, so if the explain code movement techniques, so you will write the answer. This technique is what, moving some amount of code outside the loop and placing it just before entering in the loop. And this is the example. Okay, now reduction in strength. Okay, so this techniques, in this technique, what you will do in this techniques, see, multiplication is the costly operator. That means it takes more time. And plus is what, cheaper operator. That means what, if I will do multiply this, 6 multiply 6 multiply 6, so you will take more time, right? And but if 6 plus 6 plus 6, so it is what, easy. 6 plus 6 12, and 12 plus 6 18. So but this is what, multiplication takes more time, so it is called what, it is called costly operator. Costly operator. And plus is what, it is called cheaper operator. So in the reduction in strength, we change the costly operator or higher operator into lower one. That means multiplication into plus. Okay, for example, so what is the reduction in strength? So in this technique, the higher strength operator can be replaced by lower strength operator. Okay, so here in the example you see, if I equal to 1, I less than 50, I plus plus. So count equal to I multiplication 7. So this multiplication how many times? 50 times. so it will take more time, but you can change this in what plus. So how? T equal to 7 and the loop is same 1 to 50 times, and C equal to T and T equal to T plus 7. So here what? Here multiplication, okay, and here what? Plus. So this change into plus and result will be same. Result of this and result of this is what? Same. Another example what? Here A multiply 2. So you can change what? A plus A. Okay, this is same. Maybe suppose value of A equal to what? 3. Suppose value of A equal to 3. So what is the answer of this? 6. 3 into 2, 6. And what is the answer of this? 6. 3 plus 3, 6. So the here multiplication you change into what? Plus. So this is what? Slower code, and this is what? Faster code. So this technique, name of this technique is reduction in strain. Now this dead code elimination. That means dead code elimination. Dead code elimination is what? I equal to 0. If I equal to 1, A equal to x plus 5. Right? So this I equal to 0, this is not used anywhere. What is the importance of this? I equal to 0. And in another line, here I equal to 1. Okay, I equal to 1 and here I equal to 0. That means I equal to 0 is never used. This never used in the program. Okay, so that if any code is not used in the program, so it is called what? Dead code. Okay, so what is the dead code? The variable is said to be dead at a point in a program if the value contained into it is never been used. So that code is what? Dead code. So you remove this. You can remove this one. So the code containing such variable supposed to be a dead code. For example, here I equal to 0. If I equal to 1, x a equal to x plus 5. That means if this is true, if this is true, 1 means true, or I equal to 1. So that means what? First you assign I equal to 0, and again if I equal to 1, so I equal to 1 is never. Okay, so this is what? Dead condition. So you can remove this one. So it is called what? Dead code elimination. So if a statement is a dead code, as this condition will never get satisfied. Hence, a statement can be eliminated and optimization can be done. That means first is 0, that means false. And next line, if in the condition what? I equal to 1. So I equal to 1 never comes, never. So just remove this. Okay, so only first line is executed, I equal to 0, just this. So you remove this code. It is called what? Dead code elimination techniques. Okay, so techniques of code optimization with example we have explained. Okay, 5 optimization technique with the examples. here. Next class, we will explain loops in a graph. Okay, and this is the last chapter of this course. Okay, so loops we will discuss in next class. Okay, so thank you.